Hi, this is Vaslav Turchek with Azure Service Fabric, talking to you today about ASP.NET Core running on Service Fabric as services. So when we talk about ASP.NET Core and Service Fabric, if you're doing back-end services today, back-end applications, typically you already have something like a web application, you have a web API, all these things that are talking to your front-end applications. And ideally, you're going to have a set of back-end services that are kind of individual small services all doing one individual job. This is sort of the ideal architecture that we look for. And if you're a .NET developer, you're probably doing this with ASP.NET Core already. And ASP.NET Core is actually the ideal platform to do this on, because ASP.NET Core gives you a couple things that are really, really great for this sort of architecture. So you get a lightweight framework, you get a cross-platform experience, and probably best of all is you get a self-hosting experience, which basically means that the web server and the application are actually bundled and run together in the same host process, as opposed to, say, for example, running on IIS or some other web server software that has to run on the machines themselves. And this is particularly good because you don't really want to think about servers anymore. You don't want to think about machines. You just want to think in terms of services. And being able to package that all up into a single service is really a good thing. Now, the problem you obviously run into is how do you then run these services and host them and orchestrate them across a set of machines? So you need something in order to do that, and that's where Service Fabric comes in. Service Fabric is also the cross-platform service orchestrator and distributed application platform, which makes it very easy to actually run these kinds of back-end services. So these two things, ASP.NET Core and Service Fabric, are really made for each other. Now, how do you actually host ASP.NET Core in Service Fabric? There are actually a couple ways to do this. You can put your ASP.NET Core applications into a container, for example, a Windows container, a Docker container, something like that. And this gives you a number of great features, like you get this environment isolation, you get you get resource constraints, things like that, which is really good. But they're a little bit heavy, especially on Windows. So the other way you can run these things is as a guest executable, which is if you have an existing ASP.NET Core application and you just want to take that and you just want to run it as is without integrating with any of the Service Fabric APIs or making any code changes whatsoever, you can take that as is and you can just run it on Service Fabric. So that's another thing you can do. And the other way that you can do this is you can actually host your ASP.NET Core application in Service Fabric reliable services. And this is what we're going to mainly focus on today, is how this is done with ASP.NET Core. So first, a little bit of background on how we host ASP.NET Core. Now, these typically, when you're doing self-hosting, you're kind of tied to your process lifecycle, and it's fairly simple. In your program main, in your host process, you bootstrap the web host, as the ASP.NET Core web host. And the ASP.NET Core web host is the thing that then runs the web server and your application, so whether it be MVC or a web API or whatever it is. Now, if you're hosting it in Service Fabric, this works a little bit differently. So you still have a host process, but the program main entry point actually isn't the place where you bootstrap ASP.NET Core. It's a place where you bootstrap reliable services. So in our parlance, this is where you go and you register a service type with the Service Fabric runtime. And what that does is that when you go and create a new instance of your service, or services need to be moved around for any reason, the Service Fabric runtime will then create those instances of that service in the process host. It's essentially saying, I'm allowing these types of services to run in this process. So obviously we can't do both ASP.NET Core and Service Fabric registration in the host process because the life cycles are a little bit different. So what you do instead is, in reliable services, we have this kind of plug-in model where you put in your communication stack, which is an interface implementation that we call iCommunication Listener. And it's in here where you then go and bootstrap ASP.NET Core and your web host to start up your web server and your application. So let me pause here real quick and switch over to Visual Studio just to show you what this actually looks like in code, so you have a kind of a good idea of what we're talking about. So this is one of our pretty simple getting started sample applications for Service Fabric. It's got a few services in it. Here I have a stateless ASP.NET Core service ready to go. And you can see in the program main and the entry point here, we're actually just doing service registration. This is that service type registration that I talked about with the service runtime, or with the Service Fabric runtime. And that's actually just bootstrapping this service class, which is the thing that gets created in your host process later. Now, If you look down here, this is where you actually have that plugin model, and here we're using Web Listener in this example because this is a stateless service. And in this case, what we do, these are the packages, by the way, that you get. These are the NuGet packages that come with the Service Fabric SDK. And so basically what we do is when we bootstrap this communication listener, we kick control back to you to go and set up your web host. So this code you'll see is actually fairly familiar. This is exactly what you do in your program main if you're doing ASP.NET Core just on its own. It's basically the same thing. We give you that same level of control, but it's just the life cycle that's a little bit different. Other than that, this is no different than a typical ASP.NET Core project. You have your ASP.NET Core controllers, your views, basically everything, your dependencies, all that stuff, your www root, it's all here. The only thing that's really different is that entry point has changed. And we've also added this package root, which if you use Service Fabric you're familiar with already. This is where you define some parameters about your service. If we look at a stateful service example, it actually looks very, very similar. Again, we have that same program main entry point where we register the service type. And then in the stateful service itself, we once again just bootstrap ASP.NET Core in the iCommunication Listener interface here. And in this case, we're using Kestrel because we're a backend stateful service. And we can see here when we go and configure services, this is where we can use the dependency injection system that's built in to ASP.NET Core to add some of the dependencies for ASP.NET, or for Service Fabric rather, so you can do stateful operations in your ASP.NET controller. So that's basically what it looks like in code. Let's switch back now and talk a little bit more about the life cycle here. So if you're in a stateless service, the life cycle is actually pretty simple. It's just an open and close. If you move on to stateful services, it's a little more complicated. Now you have this change role mechanism that goes through different life cycles within a single stateful replica. And it's here where we actually open and close ASP.NET Core. So we might do this multiple times through the life cycle of one of your stateful service replicas or stateless service replicas. And so the point there is that your ASP.NET Core application is no longer tied to the lifecycle of the host process, but rather to the service running in the host process. So that's the main difference there. Now, in the example I showed you, we had two services, two ASP.NET Core services that then talk to each other. So a little bit about that. The basic way this works in Service Fabric is the services, since we're no longer talking about machines, we're actually talking about just these services, they can float around a little bit. And so the problem you have to solve is figuring out where these services are. And so we have this naming service that you use to figure out where is the service that I want to talk to. Once you get that address, communication is generally direct. There are a couple of other higher level abstractions we have, but for this case, we'll just talk about direct communication between services. That's the application that has to figure out how to talk to each other, and it's really up to the application layer to determine all of these different, all these communication aspects. So encryption over the wire, identification, those sorts of things. Now, this is a shared host environment, and this causes some interesting things, like this case of a mistaken identity. So what can happen is if you have a service, for example, that opens up on one machine on port 30,000, let's say over HTTP, and then a client goes and gets that address, but doesn't make a call to the service yet. Then the service A moves on to a different node, and a new service happens to be placed on the same node and coincidentally is given the same port. Now when the client goes and tries to connect to service A, what's actually happening is it's actually connecting to service B. And it has no idea that it's doing that, and the response codes that it gets back give it no indication that it's actually connected to the wrong service. So in our Service Fabric ASP.NET Core integration packages, what we provide is this middleware that helps solve this problem by using these unique address URLs. So it takes the partition ID and the replica ID of the service, and it registers that with the naming service. But you can see the address that it actually opens the listener on doesn't have this in the URL. It's just the IP and port. But the net effect of this is that when a client or another service goes to resolve the address, it gets that unique partition ID and replica ID. So when it makes a request, it sends that on to the target service. This reaches the middleware, and the middleware will validate that this partition ID and replica ID matches the service that's currently running. And if it does match, it'll process the request normally. But if it doesn't, it's going to kick us back out with an HTTP 410. And that HTTP 410 is the client application or the other service's indication that it's talking to the wrong service. Now, of course, this only really works in a cooperative, non-hostile environment where all the services are within the same trust boundary. If they're not, you need to use something different. But in those cases, this works quite well. So let's talk about the two web servers that are available in ASP.NET Core and how they work in Service Fabric. So the first is Kestrel. Now, Kestrel is generally the preferred web server because it is a very lightweight and very fast web server built on libuv, which runs on Linux or Windows, and it's a very simple web server. So it doesn't have any sort of port sharing, URL mapping, hostname mapping, anything like that. And what this means is that when you run Kestrel on a node in a service in Service Fabric, every instance you open up must be opened up on a unique port because there's no port sharing, okay? Now this actually turns out to be a good thing because when a client connects to one of these Kestrel instances and that instance happens to move, if that service moves, the client sees a connection failure, which is actually a really good thing because it's very clear to the client that the service is no longer there. Now this is in contrast with the other web server that's available called Web Listener. Web Listener is built on the HTTP sys kernel driver, which is used by IIS, and so this is a Windows-only thing. And this actually gives you a lot of additional features like port sharing and host mapping and URL mapping, URL path mapping. So you can do something like, for example, on the same machine in 2 different processes, you can have 2 instances of Web Listener listening on the same port. Now normally you wouldn't be able to do this, but because they're all going through this kernel driver, it's a central URL registration repository sort of thing that allows you to open up multiple things on the same port. And this has a lot of useful benefits, but the problem with this is that when a client tries to connect to an instance of a service that has moved, it doesn't get a connection error because there's a good chance that there is already someone else listening on the same port. So basically the client is connecting to an IP port on a unique path, but the service is gone on that path, but the port is still open. And so what happens is HTTP sys will then return an HTTP status code instead of a connection failure. So what you end up seeing is an HTTP 503 and in some cases 404. Now those HTTP status codes already mean something obviously in HTTP, so the client doesn't necessarily know what to do about it, and this causes this is a very difficult situation for the client to be in because it doesn't know when to re-resolve and try to find a new address for this service. Now, speaking of port mapping, if you are using Web Listener, because of that port registration, you do have to register a port and a URL before you can actually open up the Web Listener on it. You can't do that yourself in the service because you don't have the credentials to do it, so you have to let Service Fabric do it for you, which runs the system. In order to do that, we have this resource endpoint configuration in your service manifest where you can say this is the port I want, and then we will do that ACLing for you and assign it to you. Now, if you're using Kestrel, obviously you don't need to do this because Kestrel doesn't use that kernel driver. But there's still some benefits to this because we will do a couple things for you. We'll take that port and we'll open it up through the firewall on the OS. And the second thing is we'll give you that port in the URL, which we pre-build for you and say, here, you can now open up your listener on this. So those are a couple of benefits there. If you're doing dynamic application port mapping, we can give you a random port from that endpoint resource. The caveat here, though, is that that port is shared by the service host. So you get one random port per service host. And again, if you have multiple replicas in the same service host, they're all going to get the same port. So Kestrel obviously can't use this because it needs unique ports, for instance. Web Listener can do this, but in our ASP.NET Core integration packages, we actually don't allow this because of the problems I mentioned earlier with clients trying to re-resolve and getting 404s and 503s, which isn't ideal. So we actually disallow this. You can do this on your own, but if you're using our packages, you wouldn't do it this way. So what does this all mean for you? Here's our recommendations for using these 2 web servers. If you're doing an internet-facing stateless service with a fixed port, so you have something open on port 80 or 443 and you're opening it out up to the internet, use Web Listener for that. You can use those host name and URL path mapping features to host multiple websites in the same cluster, which is very beneficial. You get Windows authentication and other IIS features. And of course, there's this DOS protection that you get through HTTP sys that you don't get in Kestrel as of ASP.NET Core 1.x. So you don't get that there today. So for internet-facing fixed port stateless services, Web Listener is the way to go. For internal service communication on the back end, we recommend Kestrel for that. It's a very fast server. It's very, very simple to use. There's no URL registration required, and it's definitely the ideal server for doing that. So now if we go back to our application that we saw earlier, this is what it would look like taking all that into account. We got a couple services up front serving up a UI and an API. Those are using Web Listener. And on the back end, we've got a bunch of Kestrel instances, and you can see they're using this dynamic port mapping and unique paths with partition and replica ID. So that's how we do ASP.NET Core in a nutshell on Service Fabric. If you want to learn more, come visit us on GitHub. Everything I talked about today is open source. If you come visit our repo there, you will see links to documentation, samples, and of course, source code. Thanks so much for listening.